And algorithmic thinking is really important in computer science because it is how we approach problem solving. We are always trying to think algorithmically about problems in computer science. And without even warning you, I've already been priming you for this lesson the whole semester. I've been talking about how we think algorithmically without using the magic A word because I didn't want us to get distracted by the fancy word. I just want us to think about things in a certain way. And it certainly takes practice, and it does take a lot of repetition, just like learning any skill does. But there are 3 basic steps that I want you to know about in algorithmic thinking or in creating an algorithm, and that is deconstruction, solving, and reconstruction. So when we have a problem that we're dealing with in computer science, creating the magic formula, I almost said formulae, that means I watch too much SpongeBob. I apply these things to that problem. Deconstruction is where I take the problem and I break it down into smaller pieces. We've been doing that already. Solving is where I take that, and by the way, these are recursive, which means I might get to here and I say, now I've broken the problem into 3 pieces. And I take one of those pieces, I say, I'm going to solve that problem. And I might say to myself, well, that problem is still a little complex. It's got a lot of parts still. So I might say, I'm going to take that problem and I'm going to deconstruct that problem. I'm going to break it down a little bit further until I can get to a piece where it's a simple thing for me to solve. Then I solve it, and then I start putting things back together as I solve them. If you're a visual thinker, this might help you. Imagine a bento box. Food always speaks to people, right? Bento boxes, I love them because they're so cool and artistic and organized. 3 things that I can really appreciate. Also food, 4 things. So if we have a bento box, a lot of times a bento box has little containers inside the containers, right? And sometimes there's even containers inside the containers inside the container. So if I think about this, deconstruction would mean taking the containers out of the box and even taking the containers in the container out so that I can see each little piece of that problem on its own. And when I can't break it down anymore, then I start solving those problems one at a time. And in a lot of cases, the mechanism I'm going to use to solve that problem or to create a solution is going to be a custom function. So I'm going to create a custom function that does this thing. And then it's solved. Then I have a black box with inputs and outputs. I don't have to worry about how it works. I just know that it works. I've simplified the problem, which may be 10 lines of code, down to a single function. So when I'm done, I just reassemble the whole thing with all of the problems solved, and reconstruction means that I'm done with the project and it works. We've talked about speaking in pseudocode or using comments to help us think through things. I still think that's a really great approach for complex problems. After all of the years I've spent programming, it is still something I do. This is not something like, I'm not giving you training wheels here. Like, start out with these, and when you get really good, you won't have to do this anymore. What I'm giving you is a practice that could help you 10, 15, 20, 30 years from now. When you're sitting down to code, if you are looking at how to break things down into simpler pieces, I could say, use this, print out the numbers from 1 to 200 instead of writing that code. Now, obviously, that's pretty simple code, And so maybe I don't need pseudocode for that. But if I'm planning out my code or my project using pseudocode or using regular English words that symbolize code is a valid way to do things.